Hello there, I've made a bit of a start on the MIDI, which stands for mid-size, mid-duty, okay, CNC Router. And what I've actually done is I've laid some parts out here. So this particular series of parts, or set of parts, is for the Z-axis. So what I had to work out was what was the clearance that was necessary between these bearing carriages and this bearing block, and you know, how much area that I had to create around this to make it work without anything fouling, and which gives me then the distance between the outer part of the rail here and the outer part of the rail here, and how much room then I've got on the aluminium plate material that I've got. The aluminium plate material that I picked up yesterday is 160 millimeters. So what I'm going to do is I'm going to set this top edge to the top edge of that aluminium plate, and with the clearance that I have here, it gives me just a little over 30 millimeter here. So it then gives me an area to work where I can make a solid attachment between the left side and the right side of the CNC router, because I'm having a drive screw on both sides of the y-axis. So then from that, I had to work out what the total height was and the amount of material that was going to be on the underside of this, and then deduct all that off the overall width of the machine before I could come up with the length of these. Now these are, and I'm using 5 of these. This is, let me see, 60 by 40 by 3. Now this is main sort of chassis members, or shall we say spreaders then, for want of a better word. So, I'm now going to use my motorized hacksaw to cut these all off to near length. I'll probably put them in the lathe and just face them off in the lathe, make them all nice and square. You know what I mean by putting them in here. It'll be captured in there, like that. Oops, like that, captured inside, and it'll pull up very, very solidly and square. So so that's what I'm going to be doing now this morning, is cleaning these up, cutting those off, drilling them out, milling a flat, drilling them out, and also so that will mean 2 programs I'm writing, because what I have to do is set these up in my CNC little mill, and mill a hole through here, turn it over, mill a hole, correct size, then turn it right, turn it around, do the same on the other side. So I have to set the mill up, write a program to, actually I'll mill a flat manual in this, that's take me a few minutes, and I'll write a program to cut it in the aluminium. So that's what I'm going to do today. Right, so I've cleaned all the ends of these up and I've cut all those short lengths of 20mm bright mild steel. But now all I've got to do is write a small program to cut this 20mm hole with my little CNC mill that I converted about 3 years ago now, and there's some 15 videos on how I converted this from a manual mill to a CNC mill in every detail. So it was about 3 years ago. I've actually put them together in a playlist, and if you're interested, go and have a look. So to mill this hole in here, milling it is far preferable to actually putting a drill through. It's a far cleaner hole, but you can drill it and file it. Okay? Anything that you see me doing here, you can actually do with hand tools, but it's a lot easier for me to do it with machinery. Plus you get to see how to program a CNC machine as well. Look, a CNC mill is very, very similar to a CNC router, except this will actually machine steel. Okay, very, very hard steel too. So what I'm going to do, like I say, I'm going to write a little program, a short little program of how to machine the hole in here. I'm going to cut it with probably I'd probably use a 6mm 2 flute for this little job. For a number of reasons. I don't have to put so much downward pressure on the bit to get it to bite in and cut. And because this is a 3mm wall, okay, what I've actually done is I've cut a piece of, what is this? I know it's wood. This is actually a piece of Oregon. Beautiful. It smells a little bit like oranges. Okay, so I've cut it the exact same size as this. So I just fit it in there like that. Okay, now I'm going to make a jig. Now a jig is anything that you set up to do, you know, sort of repetitive work. So you just put it into the same place all the time. So it's a tool to help you do that. Okay, so I put this in here, so when I got this clamped onto the bed and the tool comes down in, it doesn't crush this down. Okay, it's got some resistance, you know. Being aluminium, it will tend to bow slightly. Alright, so you put something in here like this to stop that bowing. The tool will bite in and cut the hole through, no problem at all. That's the idea anyway. Okay, so now it comes down to writing the program in ArtCAM DualSmith. Now, this is a program I started off with way back in 2008, I think it was. And it's still a good program. And the computer that is running this machine is an XP, actually, that I've, well, revamped, I suppose, and it works perfectly. So we're going to start off with a new job, and in our case it's going to be, in the Y it's 60mm, and in the X it's going to be 40mm. Now why I've chose that is because, you know, I just want to work on the very end and I require a hole to be in the middle of this piece of work. So let me just get the piece of material. So I want to put a hole, alright, a mill hole just there like that. And the center of that hole is 20mm in from the end. Okay, so what I'm actually tricking the program into thinking that this is the full size of the piece of material, because we're really interested in making that hole there. Now what I'm going to do is I'm going to make the orientation at the moment is in the center of the material there. Well, I'm not. I'm going to put it over here, this back corner, because the vice jaw is here, and I'm lining this edge, this corner up here, with the end of the vice jaw, so I can reproduce the position of the material very easily. Okay, you'll get to know what I mean when we start machining. So we're going to alter this to the back corner over here, which is pretty normal for a CNC mill. CNC router, you either use this front corner here or the center. CNC mill, it's back corner over there. You can put it anywhere really, but that's what is normal for a CNC mill. So what I'm going to do is I'm going to zoom you into a full screen, or big as I can get, so you can see what I do to write the program. Okay, whatever's missing off the screen down here doesn't really matter. Okay, so there is our material. So what we're going to do is come here to the drawing tools, pick a circle, and we are going to say that we want a circle of now I can actually use the wizard here to do this, so it's exactly right. Diameter, we need to be 20mm. Ooh, not that many. 20mm. And we need this to be, let me see, if we put the 0, 0 here, so we need to be minus 30 minus, oh no, there we go, minus 30 and plus 20. So that's what we're going to say here. This is plus 20. And this one minus 30. Preview. And now that's how to use the wizard to help you accurately position a hole or whatever you want to do. Now that is dead in the center of that material. I didn't have to draw it or anything like that. So we're going to say create and close. Okay, so now we're going to create a toolpath. Okay, make sure we got our hole selected, and we come down to here to toolpaths, and we want we just want a simple area clearance. So it's a 2D area clearance, start depth 0, and we're going to make the 0 the top of the material, which is fine. Finish depth, oh, we're going to go 4mm, I think, yeah, 4mm. We're not worried about allowance or final tool allowance or anything like that. Machine safe, oh, that's probably a little bit too much. We can go 10 mil here. Home position Z. Okay, so that means the machine's going to go back to this corner here, which I wanted out the way because I want to be able to undo the vise, take this out, turn it over without having to muck around, you know, sort of trying to get it underneath the tool if it was in the middle here. So this is correct for our home position. 20 mil out the way. Safe, yeah, that'll be fine. Tool and list. Out of tool. 6mm end mill. And we're going to select that. Now we're going to modify this now to suit us. 1.8. It's probably okay. I'm going to go 1.5. I'll say 1.5. I don't want to put it under any stress. Step over, step down. Oh, that's way too much. So we're going to go. I think 0.75 is fine. Feed rate 20 millimeters per second. Yeah, I'm going to sort of, I'll run with that because I can slow it up in Mark III. Plunge rate 6 millimeters a second. I'll say 5. 15,000 RPM? No. I know the maximum on this is about 4,000 RPM. Although, look, the program is not actually controlling this, you know, on this machine. I control it manually, but just for practice sake, we'll put the correct information in here. Now I don't want to do a hole with a raster. I'm going to do an offset. I always use climb milling, and I always obviously with a hole from the inside out. Add ram pins. I always use ram pins. 10-degree angle, maximum ramp length 3. Oh, I'm going to go 2 because it's only a small hole. 2 and 2. Start the ramp at 1 millimeter above the material. That's fine. Now let's set the material setup now. It is. We're going to say that it's. I'm going to say it's 4 millimeters. Yeah, 4 millimeters. 4.0 millimeters thick. Bottom offset 0 at the top, and we're going to OK that. Okay, so we'll call it something so we can recognize it. So we're going to say 20 millimeter with a 6 millimeter. Oop, that was wrong. Okay, we'll calculate it now, and there it is. And that's it. Okay, so let me see. Bring the tool down. Actually, this is just just a tool I've got in here just to find that edge, that corner there. Nice pointy tool. Okay, so we'll get rid of the MPG. So we're coming up here. All we're interested in is the X and Y, so we're going to zero that and zero that. And regen. Okay, so that puts it in the right position for us. And so now I'm going to change that tool and we'll zero the Z. Okay, so we've got a 6mm cutter in there now, and we're just going to bring down the cutter and we'll slow that up a bit. Okay, 3% should be fine. And what I'm going to do is just scratch that. Nearly there. There you go, just scratching that, I think. Yep, there we go. So we're going to call that 0. Okay, so we're ready to go. So we're going to, like I said earlier, the spindle on this is manual. So we're going to be using flood coolant as well, because this is aluminium and you require it with aluminium. So we'll start the spindle up and we'll set it all in motion.